Welcome to circles. So, as we have already discussed, a circle is a round object, obviously. And we're going to start off with a center, and I'm going to put a line out to the edge. That's called a radius. I'm going to label it with a lowercase r. Radius is the distance from the center to edge. Of a circle. I want you to put a lowercase r, and yes, the size of the letter does matter. It does need to be lowercase, not capital. And an equal sign, and hold that thought. We'll be back to that in a moment here. Now I'm going to draw another line all the way through my circle, and I'm going to label that with a lowercase d. This is our diameter. Diameter is the distance from one edge to the other through center. Okay, that part is really important, that it's through the center. If it doesn't go through the center, it's something called a chord, and while that is important to know, it is not relevant this school year, so we'll hold off on that thought. Okay, and I'm going to use lowercase d for diameter. Capital D represents distance and other things later on in math, so we want to be specific about those types of information. And diameter, as you may notice, all the way through. Radius is only halfway through. So to find a diameter, what we're going to do is I'm going to multiply the radius times 2. And going back here, I have r equals, and for that one, I am going to divide the diameter by 2 if I start with the diameter. So a lot of times you'll get a radius or a diameter when you need the other one for your area and circumference formula. So make sure you are familiar with that interaction of multiplying or dividing by 2, depending on which way you're going. Speaking of circumference, that is the distance around a circle. In other words, it's the perimeter of a circle. Not sure why we have a fancy schmancy word for it, but we do, so we'll roll with it. And that formula is one of two things. Circumference equals pi times the diameter, or circumference is equal to pi times 2 times the radius. You'll notice, based on our previous stuff here, diameter and 2 times the radius are the same thing. If you need a little ditty to help you remember it, you can either do twinkle twinkle little star, circumference equals 2 pi r, or you can remember that cherry pie is delicious. For our area, we have area is equal to pi times the radius times the radius. Now, a lot of times in the future, you're going to see area equals pi r squared, but remember that squared means that we are multiplying it by itself. So we have pirate, pirates say R, right? Or you can say apple pie R2 when you're saying cherry pie is delicious. Now, we mentioned this pi thing here a couple times. Pi is a Greek letter, looks like this. This is actually the character of the letter. I believe it's the lowercase pi in this case. And that is an irrational number that goes on forever and ever and ever and ever, without ending, without repeating. So because of the fact that it doesn't repeat and it doesn't end, we will approximate it often for our purposes in math, so we have an idea what's going on. So I use this squiggly equal sign here to approximate, and it equals approximately 3.14, hence Pi Day being March 14th. Sometimes you will see your answer, either exact answer or in terms of pi. That means an exact answer, okay? And that just means that this character, that little fancy little character there, is going to be in your final answer. Our next situation here, we're going to do some examples. So, given a radius of 7 centimeters, enter the circumference of the circle in centimeters and round your answer to the nearest hundredth. So this tells us a few things. First of all, it tells us our radius, r equals 7. It tells us we're looking for circumference, which is equal to pi times 2 times the radius. And it tells us I have to round, which means I need to use 3.14 in my answer. I'm not going to leave it in terms of pi. So I'm going to start replacing what I know. Circumference is equal to pi times 2 times, in this case, 7, because that's my r. Okay? And 2 times 7 is 14 times pi, of course. And this here, this first part here, that is what we call in terms of pi. Pi is in my answer, and that is an exact answer. But it told me to round, so I am going to continue on here by approximating 14 times 3.14. And because I have multiplied that together, I should know that my circumference is approximately 43 96 centimeters. Centimeters because we're still dealing with one dimension, as a circumference is a perimeter. For our next example, I'm starting with a radius again, this time of 7.5 centimeters, so r equals 7.5. And I want the area this time in square centimeters. And I'm being asked to round again to the nearest hundredth. So because I am being asked to round, I know that I'm going to see that 3.14 pop up again. So I'm going to use my area formula, pi times r, and I'm going to plug in r. So I have pi times 7.5 times 7.5. To get my exact answer here, I should end up with 56 25 pi, okay? Everything is exact. But I was told to round, so I am going to use my squiggly equal sign, and I'm going to plug in pi here, 56.25 times 3.14, which gives me approximately 176 625 thousandths centimeters squared. But it said I need to round to the nearest hundredth, so in this case I do need to take a look here at that hundredths place. 176.6 is all good, but that 2 and the 5 after it tells me I round that up to 3, and that gives me a final answer of 176 63 hundredths centimeters squared. Sorry, not cubed, squared. Okay? This one is a you try. I strongly encourage you to write down your formulas. Notice that area is first, circumference is second. And to make sure you are marking your text, circling, and underlining important information. All right, in this example, we have a circumference of a circle is 31.4 inches, and we want to enter the radius. So I'm looking for the radius, and I'm given the circumference, which is equal to pi times the diameter, or pi times 2 times r. I'm going to go with pi times diameter in this case. And this one is a little bit different than the previous example because this time I was given a circumference, I wasn't given a radius or diameter. So I'm going to plug in 31.4 or substitute 31.4 in for C. 31.4 is equal to pi times the diameter. Now, my goal is to find the radius, which means I need to solve for the diameter so I can work my way back to my radius. So I'm going to divide both sides, because this is multiplication, and I'm doing the inverse operation, by 3.14, because that's what we use to represent pi. So that cancels out. I end up with D, for diameter, is equal to 10 when I divide 31.4 by 3.14. But my radius is equal to diameter divided by 2. And I'm looking for a radius, not a diameter. So I'm going to divide the diameter by 2. And if I do it to one side, I do it to the other. 10 divided by 2 is going to give me a radius of 5. All right, so I want you to try the top one. This top one here. And the bottom one we'll take a look at together. So go ahead and pause the video, try the top one, get it checked off, and then continue the video so we can take a look at the bottom. So Jill buys 2 circular pizzas. The small pizza has an 8-inch diameter, and the medium pizza has a 12-inch diameter. How much greater in square inches is the area of the medium pizza than the small pizza? How much greater is the area? Now, I mentioned this in class, but square inches is not the same as regular inches, so I can't just subtract the diameters or the radii at this point. I have to put it in area form first before I can subtract. So, it also tells me to round, so I'm going to have to use my pi at some point. So what I'm going to do here is I am going to go ahead and find the radius, because my area is what I'm looking for, and that's pi times r times r. So I need a radius to be able to calculate area. So r is equal to 4 because r is the diameter divided by 2. And then for this one, r is equal to 6 because 12 divided by 2. Okay? So the area of my small pizza is going to be pi times 4 times 4. And the area of my medium pizza is going to be pi times 6 times 6. So 16 pi and 36 pi. Now, because they're both in terms of pi, I can subtract them like this. So what I'm going to do is I'm going to take 36 pi minus 16 pi, and I get 20 pi. They're like terms right now. But I need my answer at the nearest tenth, so I'm going to now multiply this by 3.14. So 20 times 3.14 gives me an approximate answer of 62.8. Moving on here, we have an artist use silver wire to make a square that has a perimeter of 40 inches. She then used copper wire to make the largest circle she could fit in the square as shown below. How many more inches of silver wire did the artist use compared to copper wire? So we're going to use 3.14 for pi to compare them, and we'll show all of our work. So first things first is I need to recognize that the perimeter of 40 inches, so the silver, she used 40 inches of wire, okay? But I need to know what my radius is to be able to find area of my circle. So the square is the diameter. It's the entire length across. I could move this down and see that it matches up. Because of that, I need to know the side length of each of the sides. Well, if it's 40 altogether, a square's side lengths are all the same, so that means that the diameter is 10. But again, I just said I need a radius, which means that my radius is going to be half of 10, or 5. So let's find the area of this copper circle, okay? So the area is equal to pi times r, which is 5 times 5. So I get 25 times 3.14. This gives me approximately 78.5. All right, go ahead and give this one a shot, and then continue, and give this one a shot, and then continue, and give these last couple a shot, and then make sure you get them checked out. Good luck. Make sure you take a look at this example stem 2 here, that the circumference is what you're given to start, and you are just working with 3/10 of the whole circle. Strongly recommend that you find a formula first with this 3/10 added onto that formula, or multiplied in this case by that formula, and then plug in your appropriate numbers. Good luck. Have fun.